students, welcome to the VAIR community. At VAIR, we have a parallel where we record videos every week in which we discuss one particular set from the previous year's CAT questions from LRDI. Here's another one for you today, which is from CAT 2022. Let's take a look at the set. We have a lot of information given to us through the set. Let's take a look at each and every piece of information, and then let's try and figure out how to solve the set as well. A, B, C, D, E, and F are the interviewers in a process that awards funding for new initiatives. Every interviewer individually interviews each of the candidates individually and awards a token only if she recommends funding. A token has a face value of 2, 3, 5, 7, 11, or 13. Each interviewer awards tokens of a single face value only. Once all 6 interviews are over for a candidate, the candidate receives a funding that is ₹1,000 times the product of the face values of all the tokens. For example, if a candidate has tokens with a face values 2, 5, and 7, then they get a funding of ₹10,000 multiplied with 2 into 5 into 7, which is ₹70,000. So we have some interviewers, that is 6 interviewers, who can award tokens to the interviewees, which are of the face values 2, 3, 5, 7, 11, or 13. They have said that each interviewer awards tokens of a single face value only. That means one interviewer at a time can only award tokens of one single face value. For example, if I take Esther and we decide that Esther has only tokens of face value 2 to distribute, then Esther can only distribute 2s. On the other hand, Chaya can maybe only distribute 11s or only 13s. So each one has one particular denomination or one particular face value to distribute among the students, among the candidates. Pragnya, Kaira, Rashida, Smira, and Tantra were 5 candidates who received funding. The funds they received in descending order were ₹3,90,000, ₹2,10,000, ₹1,65,000, ₹77,000, and ₹66,000. Now, this is not in order clearly. They have only put it in descending order, but that does not mean that the first number here corresponds to the first candidate here. It can be in any order, and that is what the question is all about. The following additional facts are known. Fatima awarded tokens to everyone except Q, while A awarded tokens to no one except P. So we'll come to these nitty-gritties in a bit. R received the highest number of tokens that anyone received, but she did not receive one from E. B awarded a token to S, but not to Q, while D awarded a token to Q, but not to S. So there are multiple conditions that are given to us over here. Clearly, the question is asking us to kind of play match the following, where we have certain interviewers, we have certain candidates, and there are certain amounts that are distributed depending on the tokens that they have received from the interviewers. So we have to play match the following about which amount could belong to which of the candidates and who has given which kind of a token to whom as such. Let's quickly glance through the questions that followed in this particular set so that we have an idea about what would be the approach to the question, because we have to answer them at the end. The first question is how many tokens did Q receive? So there is a definite answer to how many tokens Q received. Because this is a type in the answer question, there are no options. So there is a definite number of tokens that Q has received. Here there are options. Who among the following definitely received a token from B, but not from D? Now, since the word definitely has come into picture, there could be some amount of not surety that is there in our solution. Since the word definitely has come in the picture, there might be a little bit of some missing information or some information that is not absolutely true when it comes to the solution of our set. How many tokens did C receive? How many tokens did C award? Again, it's a definite answer. There has to be one single number. How many tokens did S receive? Again, a definite answer. And which of the following could be the amount of funding that T received? It's either 66 or 165, both A and B, neither A nor B, only A, only B. So again, there is a possibility of your information not being entirely given to you because the question asks you could be. And there are multiple options as well, which can have combinations of these values as well. So we know for now that the questions are not exactly very definite questions. There are some questions which will depend on cases. So the information that is given to us is not entirely enough to get to definite answers for all the questions. Now let's go back to the set and let's try and solve it. So here is all the information that we have, and this is the representation that you would have. So here is all the information that we have from the set, and we will have to represent it in some manner so as to write down these values in front of the people or the candidates who have received them and the tokens that have been distributed by the interviewers as well. Taking a look at the tokens, all of these are basically your prime numbers. And if I take a look at my fundings as well, they are all multiples of thousands because it is 1,000 times the multiplication of the tokens that have been received by each of the candidates. So what we're going to do first is we are going to break down each of these numbers into its token face values. Since everything is a multiple of 1,000, I am eliminating 1,000, or I'm writing 1,000 separately. And then let's see what is the rest of the number that can be broken down into who has received which token as such. Starting with 66,000, we know for sure that 66 out of these face values, it has to be multiples of some face value tokens. So let's start with writing down these particular combinations. 66,000 can be written as 1,000 multiplied with the product of the face values of the tokens that this person has received, which means 66,000 has to be a multiple of either of these numbers. Now I have the remaining bit, which is 66. 66 can be factorized as 6 into 11. Now, since we don't have a token with 6 as a face value, 6 will further be factorized as 2 into 3. So we have 66,000 formed by 2, 3, and 11. Likewise, if we go to 77,000, this is 1,000 multiplied with, now 77 is formed by a 7 and an 11. Both of these numbers are there in our tokens. So this becomes a 7 times 11. The next number we have is 165,000, which is 1,000 into 165. Now 165 is basically 15 into 11. Once again, we don't have a 15, but we have a 3 and we have a 5. So this can be broken down as 3 into 5 into 11. So we're done with 3 values as of now. The next number we have is 210,000. That's another 1,000 into 210. 210 is a multiple of 7. So we have this as 7 into 3 into 10. Now I do have a 3 and I do have a 7 in my tokens. However, I don't have a 10. Now 10 can be additionally formed using a 2 and a 5. So I have to break it down further. So this is basically 2 into 3 into 5 into 7. This gives me the value of 210,000. And the last funding amount that we have is 390,000. Similar to what we did for the previous number, this is also a 390 now. 390 is a multiple of 13, and that is 13 into 3. That becomes 39, and then another 10 followed by a 10. So 10 is made up of 2 and 5 anyway. So I have a 2, I have a 3, I have a 5, and I have a 13 in order to make the 390. These are all the breakdowns of all the funds that have been received by these 5 candidates. Now we'll have to plug in these values depending on who has received which tokens and who has not received those tokens. Let's take a look at the tokens that have been distributed then. 1,000 is there in the formula itself for funding, so we don't have to worry about the 1,000 at all. My tokens are all of these prime numbers that I can see after the 1,000. We are going to look at how many 2s were distributed, how many 3s were distributed, how many 5s were distributed, how many 7s, how many 11s, and how many 13s. If I see the number of 2s distributed, I have a 2 distributed here, I have a 2 here, and I have a 2 here. That means there were 3 2s that were distributed. So the interviewer who has the face value of the tokens 3, the token of face value 2 has been distributed once, twice, and thrice, 3 times. So 2 has been distributed 3 times. What about the token 3? Token 3 is repeated here, 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 and here. So 3 has been distributed 4 times. 5 has been distributed thrice. 7 has been distributed just twice. 11 has been distributed 3 times, and 13 has been distributed once. So we know the distribution of the tokens also. We know how many tokens of each face value were distributed among the candidates. Looking at the additional facts now, we know that F awarded tokens to everyone except Kaira. So F has awarded tokens to everyone, that is P, R, S, and T, except for Kaira. A awarded tokens to no one except P. A awarded tokens to nobody except for P. So A has awarded to P and not to anybody else. R received the highest number of tokens that anyone received. So for R, the value number of the tokens is the highest. But she did not receive one from Esther. So E has not given a token to R. And even then, R has got the highest number of tokens. It says the highest number of tokens. It doesn't mean the highest value. B awarded a token to S, but not to Q. B awarded a token to S, but not to Q. While D awarded a token to Q, but not to S. D has awarded a token to Q, but not to S. This is all the information we have from the additional facts so far. Let's take a look at what could be fitted into which part of the table. Now we know that there has been only a single token of 13 that has been sent out. So who could be the interviewer who has all the tokens of 13 with her? 13, there is a single token. So that means only one candidate has received 13, which is a candidate whose value is 390,000. If I see the interviewers lists here, I can see that A has sent out only one token. A has not given the same token to anybody else. A, therefore, has to be the person with the token numbers of 13. And A has given 13 only to P, which means P now has been masked with the value of 390,000 because nobody else has a 13 in their amounts. So 13 has been given by A to P, and P's funding has been 390,000. Let's fill this information into the table. Which means interviewer A has all the tokens of 13 with her. Accordingly, we can try and figure out what were the other tokens given to P such that the sum becomes 390. Now we know that 2, 3, and 5 are still left to be distributed, but we have 4 more interviewers here. So we can't pinpoint on which interviewer has which tokens to distribute. Is there anything else that can be filled from the table according to an implied kind of a way from the data given? If we take a look at F, that is interviewer F, F has given tokens to everybody except for P. That means F has sent out 4 tokens. Now, which denomination or which face value has 4 tokens sent out? There are 3 2s, there are 4 3s. That means F must have given or distributed 3s because there are 4 of them that have been given away. So F has distributed 3s. Let's fill in the 3s for all the other people. So 3s are also taken care of. 3s have been gone to F. So A has token numbers with 13. F has token numbers with 3. Now, if I again take a look at Q has not received a 3. How many of my place values or how many of my values of the funds do not have a 3 in them? There is a 3 in 66. There is no 3 in 77. There is a 3 in 165. There is a 3 in 210. And there is a 3 in 390. Which means if Q has not received a 3, Q cannot make for a value which is a multiple of 3. That means 77,000 belongs to Q. Because there is no 3 given to Q, Q has to have made the 70,000 in funds. So now for 77,000, you need a 7 and an 11. That means one of these people has distributed 7 and one of these people has distributed an 11. So B does not have a 7 or an 11 and F has a 3 we've seen already. B is eliminated from 7 and 11 because B has not given anything to Q. Now, let's come back to one more statement that we had, which is R received the highest number of tokens that anyone received. So if we take a look at the highest number of tokens, what is the highest number that anybody has received? 66,000 has 3 tokens. 77 has 2 tokens. This has 3 tokens. This has 4 tokens. And this has 4 tokens. So we have 4 tokens as the maximum. One set of the values has already gone to P. So R cannot score a 390 again. That means R's value of the funding would have been 210. So this is a 210. This makes up for a 210. If this is understood, let's go forward with it. So maximum, 2 people can be sharing a maximum. I know about R receiving the highest number of tokens. They've not mentioned that P also has received the highest number of tokens. R received the highest number of tokens does not imply that nobody else has got the same number of tokens. Right? So we cannot have a wrong conclusion drawn from one-sided information given like that. So this makes up for 210. Now, if I clearly observe, 210 has a 2, 5, and 7 left to be done. A 7 is common between Q and R. A 7 is common between Q and R. If I take a look, F has given a 3, so that's out of the perspective. E cannot be a 7 because R also has to have a 7. That means E cannot be a 7. If E is not a 7, what can E be? What all are the possible face values left for E to take from? So I have my values as 2, 3, 5, 7, 11, and 13. 13 has already gone to A. 3 has already gone to F. E cannot be a 7 is what we just saw because E is not giving anything to R. So this cannot be a 7 here because if E gives a 7 to Q, E must also give a 7 to R. Therefore, E is not about 7. Right? So what can E be after it is not this as well? For R, I need a 2, a 5, and a 7. For P, I also need a 2 and a 5 left from amongst all of these. So which value can I put in so that I get at least something for E? 3 is already out, 13 is already out. E cannot be a 2 either because 77 is not a multiple of 2. It's not an even number. So 2 is out. Can I have a 5 or can I have an 11? If E gives out a 5, Q must be a multiple of 5, which it is not. So it cannot be a 5 either. That means 5 is also eliminated for E, and E is left with only one denomination, which is 11. That means E has definitely distributed 11. So for E, we fix in 11 as the denomination. So E belongs to 11. So 11 is taken care of. Now 11 is distributed to 3 people. 11 is distributed to 3 people. The person who's got 77, the person who's got 165, and the person who's got 66,000. Now, if I take a look at this, 390 does not have an 11, so E has not given anything to P. 77 and 210 are gone. That means the only possible values for S and T that are left are the other two remaining values, which is 66 and 165. I'm not yet sure of who has got which, but if S has got 66, S will need an 11. If S has got 165, also S will require an 11. The same thing goes for T as well. If T is the one who's got 66, it will require an 11. If T is the one who's got 165, it will still require an 11. So 11 has been distributed amongst Q, S, and T. And therefore, E has not given any token out to P. So I am crossing out P for E. So 11 is taken care of now. So we have values for 13. We know who has given out 3s. We know who has given out 11s. So the values that are now left to be distributed are 2, 5, and 7. In order to make Q's 77, we know that we need a 7. Nothing else is remaining. Only 7 is remaining because we already have an 11. And we also know that D has definitely awarded a token to Q. D has definitely awarded a token to Q. So D has to be the person holding all the tokens of 7 because D has given something to Q. And that has to be the next number, the only other number that is remaining for Q to complete the 77,000. So D has awarded 7 to Q. That means D has all the tokens of 7 with her. So D is 7. So 7 is also out. So D has the tokens of 7 with her. Now, who else gets a 7? 7 has been distributed twice. So there's one 7 distributed in 77, and there's another 7 distributed in 210, which means R is also given the 7. None of the other values require a 7. That means D is crossed out for all the other people as well. C does not need to give anything to Q now because Q's values are done. So C does not have anything to give to Q because I don't need any other number. For 77, I need a 7 and an 11 and it is done. Now between B and C, we have 2 and 5 to be given away. I just know that B has definitely given something to S. Is there anything else that can be filled up to definitely determine what could be the values? Now here, even if I take a look at R, for R, I have 210. So I know that 7 and 3 are taken care of. 2 and 5 are still remaining, which has to be between B and C. So these two are to be filled. These two are also to be filled. And amongst these, I need to check according to my values. 66,000 has a 2 and a 3 and an 11. 3 and 11 are there with both of them. This could be either a 2 if S has got 66, or it could be a 5 if S has got 165 and C could be a 2. So I can't determine from the information that I have right now about B and C, what could be B's tokens and what could be C's tokens. This is what is the hint that was given in the questions to you. The questions were not definite, they were not direct, not all of them. Some of the questions had a possibility condition. Which of the following could be the answer, or how, which of the following could have scored so much or got so much in funding, etc. And then either A or B, both A and B. These were also there in the options, which definitely tells us that it is all right if your table is not complete per se, but you will have to go forward and take a look at the questions and answer the questions from the information that we have already filled so far. So just to write for S and T, they could either have the scores of 66 or 165, and likewise for T as well, 165 or 66. Let's now take a look at the questions one by one. Between B and C, the values of the tokens could be 5 or 2. This is not definitely known. All right, let's carry forward this table to the questions and let's answer the questions based on the table. My first question is, how many tokens did Kyra receive? If I look at Kyra's column, I know that Kyra has received a token of 7 and a token of 11 in order to make the 77, which means Kyra has received a maximum of 2 tokens. So my answer here will be 2. Going to the next question. Who among the following definitely received a token from B but not from D? Definitely received a token from B but not from D. So people who have received tokens from B are P, R, S, and T. So they could be an answer, either P or R or S or T. But these people have not received a token from D. Definitely not received a token from D. P has not received a token from D for sure. So P could be one of the answers. Q is not on the list. R has received a token from B, but has also received a token from D. So R cannot be the answer. Let's eliminate our answers along the way. So Q cannot be an answer. R cannot be an answer. P can be one. What about T? T has received a token from B, but not from D. So also has S. But S is not there in the options. But T could have received from B and not from D, only if T does not require a 7 and B has given T the number that T requires. For example, if B has sending out 2s, if T has 165 as the value, 165 does not need a 2. But if T has 66 as the value, then that requires a 2. So this is not definite right now because I don't know which one among B and C is giving out the 2s or the 5s. But I know for a fact that for P, I need both. I need a 2 and I need a 5. So B, irrespective of whether B is sending out 2s or B is sending out 5s, I know that P is going to require 1 token from B for sure. Even if it is B, even if it is 2, P will require it. Even if it is 5, P will require it. And P has definitely not received anything from D. That is why our answer is going to be P, because definitely received a token from B, but not D, is going to be P alone. So our answer for this question is the third option. The next question is, how many tokens did C award? C has awarded how many tokens? Now, P requires a 5 and a 2 for sure. What about R? Does R require a 5 and a 2? Yes, R also requires a 5 and a 2 because they have to make the 10. So P and R are definitely given tokens from C. And what about between S and T? It again depends on which one of them is going to require the 2, which one of them is going to require the 5. One of them will require a 2, the one who has 66, and the other one is going to require the 5, the one which has 165. So in either case, if C is sending out fives, there's P, R, and one of these who's going to require the five. If C is sending out twos, there's going to be P, R, and the other one who's going to require the two. That means Chaya has sent out 3 tokens for sure. Whether the value be 2 or whether the value be 5, the answer will be 3 tokens. Let's take a look at question number 4. How many tokens did S receive? How many tokens did S receive? Again, it's a definite answer. Now, if there is a 66 formed, I have an 11 and a 3, which makes it 33. So I am left with 2. That means 1 token of 2 to be received. That means 1 token more. So that will give me 3 tokens in total if S is at 66. On the other hand, if S is at 165, how many more tokens are required? So I have an 11 and a 3, 33 already. And that multiplied with 5 is going to give me 165. So I need 1 more token of 5, right? Which means in either case, S is going to require 3 tokens. So my answer for this question also is going to be a solid 3. The last question of the set, which of the following could be the amount of funding that T received? Now we know that T, definite answer, is not on the list. Therefore, it's going to be either 66,000 or 165,000. That means it could be both A and B. Which of the following could be? So D could either be A or it could be B as well. So my answer is going to be both A and B. So here we come to an end with this particular set of CAT 2022. If you want to follow many more sets like these, there is a description given in So here we come to an end for this particular set. It has been a little bit of a lengthy set, but most of the CAT sets are like that. Some of them are a lot more easier than this. Some of them are a lot more tougher than this as well. If you want to follow us for more such LR sets, then there is a link given in the description. Do follow the VAIR community for more such resources. Thank you.